Alright guys, this video is going to show you how to solve Mol-mol stoichiometry conversion problems. So stoichiometry is really just moles with chemical reactions. So every problem you're going to have a chemical reaction and you're going to have some kind of number in there. So the simplest type we can do is when the number given in the problem is moles, we're going to start with one substance and we're going to switch to another. Every stoichiometry problem, we need to balance the chemical equation. I put blanks here to show you that this reaction is not balanced. We've got a double replacement reaction. If we put a 3 in front of this one, that'll balance the acetate, the C2H3O2 on both sides. And if we put a 3 here, that finishes balancing the reaction. So what we're doing here is we're saying that in this reaction, we need 3 of this is the acetic acid, 3 acetic acid molecules to react with 1 aluminum hydroxide, AlOH3. And that will form 3 H2Os and 1 AlC2H3O2. That works for molecules, atoms, and it also works for moles. So when we want to switch substances, we're going to be in moles. For the problems today, you're just starting in moles and ending in moles. So the way this is going to work, remember, for every dimensional analysis problem, you grab the number from the problem, and with stoichiometry, we also want the substance. So acetic acid, that is the HC2H3O2. We're going to write that whole thing as our starting value. So that would be 7.2 moles of HC2H3O2. And we need a placeholder under there. And we're going to be multiplying that by 1 fraction. So with these problems, all you have to do is switch substances. To switch substances, we put moles, we want it diagonal, so that they can cancel out, of what we started with, and moles of the one we're looking for in the problem will go on top. So this one is moles of aluminum hydroxide. That is going to be this one here, the other reactant. We can use any substance in the reaction. We're going to start with one and with another. Any other substances we just ignore for now. So moles of the acetic acid, HC2H3O2, should go on the bottom. And moles of aluminum hydroxide, which is AlOH3, go on the top. And the numbers are the numbers from the balanced equation. So the acetic acid has a 3 in front of it, so we're going to put a 3 there. Aluminum hydroxide doesn't have a number, which means it's 1, so that's going to be 1 there. So all of these are just the coefficients, the numbers in front, from the balanced equation. We can cross out the moles of the one we started with. We'll get moles of aluminum hydroxide. And this one in your calculator, because you have 7.2 on top and then 3 on the bottom, you're going to be dividing. So that's going to be 7.2 divided by 3, which gives you 2.4 moles of AlOH3. Now, when it comes to sig figs, for these problems, the sig figs are determined by your starting value. Because this conversion factor here, the coefficients from the reaction, they're considered exact. You make exactly one of, or you use exactly 3 of these to 1 of these. It's a counted number. So just always match your sig figs from the starting value when you're doing these problems. So that's it. That's your final answer. Quick review. Number from the problem, including what substance you're talking about. Diagonal. Moles of the starting value moles of what you're looking for. The numbers that are here are the numbers in front of the substances from the balanced equation. All right, so you're going to do number 2, and you're going to check your answer. The correct answer is 0.603 moles. I want you to show your work, and you're going to submit that to the Schoology assignment.